Hello, sir, you are not audible.
Yes, good morning, ma'am.
Good morning, sir.
I was going through the last lecture slide. Mm, Good morning, dear Ganesh. Thank you. Mm, Okay, this will be there. Mm, Okay. Mm, Give me some time. I'm not able to. I don't see the share option here. Mm,
Uh,
I don't see the share option, ma'am. Actually.
Kali,
Mm,
on the right hand side,
Okay.
sir.
Mhm.
Otherwise, below,
No, I'll do one thing.
above the taskbar.
Only host, share, only host, and share, yes. Okay, fine. Only host, okay. There was this issue. Yeah, now I am able to share it. Are you able to see this, ma'am, now?
Yes, sir. Right
Fine.
now it is visible.
Okay, fine. Thank you. Dear students, good morning. Uh, I gave you one problem for homework. I hope you have tried to solve at your end. Uh, so let's start our session. Be, give me some time so that I have everything in place. Okay, let us start. There are students coming in. Actually, I've asked you to solve. Let me draw the diagram so that, and we'll try to solve that as well. In fact, this is by branch analysis we want to solve. Right. This was the problem which I asked you to solve at home. This was, and this is the internal resistance. If you wish to assume, you can assume that this is the battery we have, right? And we wanted to get the voltage across each resistance, right? That is whatever the resistances we have. Now, instead of, I can name this resistance R1, R2, and R3, and then find out the voltage across all the resistances. What will be the drop across the resistance? What I mean to say is, what will be the drop across these resistances? So we need to solve this by branch analysis, and we know what are the steps which we have to follow, right? So let us try to solve this one. This one using branch analysis. Now in this problem, I'll do something different, which we have, up till now, we have not considered that junction. Let us consider a different junction. In previous few problems, we have considered only this junction, right? This one. Rather than going for this junction, I used to name this as A. Rather than going for this junction, I'll go for different junction. So let me, instead of going for B, this junction, let us go for this junction, the junction just opposite to it, and I'll go for this one now, right? So my first step is I'm applying step 1, that is, I keep on saying, if you want me to write, I'll write down, assume unknown current at a junction and apply KCL carefully, right? Apply carefully. Don't write this. Apply KCL carefully. Very important, because I've chosen different junction now. So I know, I mean, this battery is going to give out the current, and they are obviously going to flow like this. So let us call this current as I1. And so I can choose either of these two, right? To start with, I mean, the first step is to choose a unknown direction of current, and we need to apply a KCL at that junction, right? So I've chosen a different junction, wherein I'll apply KCL, right? And in previous problem, we have seen that whenever the source is there, it is wise to choose that source is supplying current, right? Rather than it is taking current. So here, in some of the problem which we are going to, complex problem which we are going to solve later, there you will find that source is taking current. So we'll see that problem also. But right now here, what I observe when I look at the circuit, what I see is this 10 volt is supplying current, right? So it is wise to choose this way. Otherwise, we'll get a negative answer, and we have solved this. No, in last lecture we have discussed what happens if I take a reverse direction of a current. Please abstain from going into a chat box, because it pops up now and then whenever you post some message. So it disturbs me. For a while, we'll have a 5-minute, madam, we'll have a discussion with you later on in this lecture, right? So please don't right now concentrate whatever you are looking at on your screen. Try to understand this problem, because every lecture we are trying to learn something new, and you need to practice at your end, right? Otherwise you'll miss some of the important concept. Anyway, so this battery is going to give the current out, right? And these currents are flowing through the given branch, right? It is going to, let us call this one is R1, so that R2, because all resistances are same, and this, so current are flowing through R2 and R3 resistance, and now we want to apply a KCL at this junction. So what I see here is I1 is coming towards the junction. It has to be positive, right? Then I2 is also coming towards the junction. We assume that incoming current is consider positive, that is the sign convention when you use KCL, right? So if I choose this one is I3, unnecessarily I will be having one more uh, no current, which is ultimately is the addition of these two, right? So instead of writing I3, uh, so I3 will be what? If for sake of convenience to apply KCL, I have considered I3, right? So this will be your KCL at this junction. Let us name this junction as E, right? I'll use different one. This one is E, right? This one is E. So what I observed here is your I3 is I1 plus I2, right? So instead of writing down I3, why let us write down I1 plus I2, right? So I'm doing nothing. I'm just trying to apply this step one, right? I've applied that across this junction. You can apply it over here, doesn't matter, right? But some of the students may have a doubt, why every time I take this junction, why can't I use this junction to apply KCL? That is fine. So let us, then second step is, what is the second step we have is, uh, mm, label it, right? Label the nodes, right? So let us start from here. A, this one is B, this one is C, this one is D, E, and this one is F, right? Then step 3 is to choose any two closed path and apply KVL, right? You can go clockwise, anti-clockwise, doesn't matter. Uh, mm, After labeling, we need to, no, I forgot this step. After labeling the nodes, we need to use
KVL.
sign convention.
Sign convention. After that.
Sign convention across resistance and the source, right? Across resistances, right? This is the step 2, right? Use sign convention across resistances and sources, whatever the source we have. We have already marked polarity of battery, right? It won't change. Now this current is flowing upward. Now look at this, I1 plus I2 is actually flowing. That is your I3 is supplied by this battery. So that is what this end will be positive and this end will be negative. Many times, say for example, here, I just want to uh, see if I could draw this branch only, wherein you see this battery is connected in series with this 2 ohm resistance. This end is obviously positive, it remain positive because source we cannot change once it is in the circuit. But if it is taking current, see if it is, this source is taking current, then many times student inadvertently put plus sign over here. By mistake they do something like this, that they consider as this polarity is positive, this has to be positive. No, that is not the case. Don't go by that, because this sign convention are being used based on your direction of a current, right? See, what is the step we follow? We follow KCL, then we label it, but based on the direction of current, use sign convention across resistance and source. This won't change, this won't change, but this resistance polarity, that is the sign convention, it depends on whether the current is in this direction or in this direction, right? So don't do that ever, because you need to look at the current. So if current is flowing in this direction, let me use this colors. If current is flowing in downward direction, this will be positive and this will be negative. That this end will be negative, and this battery is positive and negative. So keep in mind that students often commit this mistake. They consider that this is positive, uh, this will also, this end will be positive. I mean, they don't apply sign conventional properly. right? It is based on a current. Now I'll draw this circuit again and I will try to explain again. See, this is positive, it won't change, right? Now, if I want, say for example, this is supplying current. What will be the polarity, I mean, sign conventions for 2 ohm? This will be positive and this will be negative. Now, how I am deciding this positive and negative based on the direction of current, right? And same I've done over here, right? Same in this problem I've done, right? So please keep this in mind. Many times students do commit mistake in this, right? Let me erase this because this was important point because resistance was in series with the battery. So I thought it is important at this moment to explain some of the important points, right? Anyway, so we have applied now step
So
4 is to,
once
yes.
again, please can you explain the how to consider the direction of current?
Okay.
Once
The previous which okay.
initial current direction, which we have assumed.
See
I1.
which one? This one. Okay,
Ha.
this one. See, this one I have chosen. See, this battery. See, the battery. This end is positive. This is going to supply a current, right? It is a source. So current obviously going to flow in this direction, right? So let us assume it is supplying current. So it has only two parallel path. Either it will, it doesn't have any other path. So it will flow from this resistance, that is R2, and it also flow through R3. And that is why I've chosen this I1 and I2. And that is why I keep on saying it is always, you know, better to choose the direction of current for a given circuit. So for example, if you are having a doubt, okay, let me draw this circuit, say for example, uh, this one. Same circuit, and I've the topology is different, right? The 2 ohm resistance, 2 ohm resistance, and 2 ohm. This one is 2 ohm, this one is also 2 ohm, and this is 10 volt, right? Now, where do we see the source? Source is in this branch, right? So it is obviously going to supply current, right? So let us call this current as, let us call this is I1, right? Right? So this I1 current, some of the current will flow through this branch. Let us call this is I2. So how much is left, right? We are applying KCL at this junction. You can apply KCL at this junction also, but for this problem, see, I'm looking at this circuit and I'm looking at the source. Source, only one source is going to supply a current. It is not going to take a current. That is very obvious in the circuit, right? Now, if you have a different voltage source, say for example, if you have a circuit like this, we'll solve this as well. And so if this is 10 volt, this is 5 volt, this one is say R1, R2 and R3. So in this case, these two battery are going to supply current to this branch, right? Uh, and it may happen that you have one more source at 20 volt. Then the things will be different, right? So ultimately what you need to do is, that is why I keep writing these steps. Assume unknown current, don't afraid to apply the assume the unknown current. Go, don't hesitate, go for it. But while going for uh, assuming the current, apply KCL properly, otherwise you will end up getting wrong answer. What do you mean by that? You can see, this is the junction, we have discussed this. So for example, this one is I1, this one is I2. How much current will pass through this is I1 minus I2, right? And if I talk in terms of magnitude now, probably you'll get that. See, 10 ampere current is coming towards the junction, right? 5 ampere is flowing away from the junction. How much will go from this branch? It will be 5 away, 5 ampere current going away from the junction, right? That is what exactly I'm doing over here, right? I'm applying KCL at a junction. So it doesn't matter, even if you choose the wrong direction of a current, you will end up getting negative answer. That we have solved in last lecture. That problem we have solved, right? So don't worry about assuming the unknown current direction. But keep in mind that you need to apply KCL properly at a given junction. Otherwise you will get wrong answer. So what do you mean by that? See, if you put plus sign over here, you will get a wrong answer. Because see, what KCL says for this given junction, what I can write down is I1 plus I1, right? What do I write down for this is minus I2, and it is going away from it, right? So I need to put minus I1 minus I2. Now, what will happen when I solve this? Are you going to get a 0? See, this gets cancelled out, right? It's going to get 0. So if you put positive here, if you put positive, what will happen? You are not going to get 0. But we don't do this every time, no? When we apply KCL, we don't actually do this. What we assume is, let us assume this is a 10 ampere current, 5 ampere is through this R3, and remaining 10 minus 5 will flow from this. We directly do that, right? And it is inconvenient to do this, follow this step every time. Every time it is inconvenient. So instead of that, this requires little practice at your end, dear friend. So this first step is, every time students fail to follow this step, because I don't know, they somehow they commit mistakes by putting a negative sign or positive sign, and they are not comfortable with KCL, applying KCL, and this is only for a 2 loop. What if we have a 3 loop circuit? What we have I1, I2, I3? Then things, sometimes things becomes difficult. So this all required a practice at your end, right? So I hope I've cleared your doubt. Please try to apply KCL for a given junction. Consider any junction, solve numerical on that, have a practice at your end so that you'll understand, right? So I hope I've cleared your doubt, but then if you're not happy still, we can always communicate, and we are there to guide you, don't worry, right? Anyway, so where were we? Step 3, right? And I explained this direction, whatever the direction we are considering is based on, that is the polarity given to the sign convention being used across the resistance are based on the direction of current. So keep that in mind. Let me erase unnecessary things which are there, right? So this one is, oops, this is, let me write down, this one is I1 plus I2, right? Anyway, so now what we can do is we can apply, fourth step is apply KVL to any 2 loops, right? Any 2 loops, apply KVL. You can either go, you can go clockwise. We have seen this in last lecture. Either, or you can go anti-clockwise. And often I'm not comfortable with going anti-clockwise. No, I have a practice of going clockwise. So pardon me for that. But I'm comfortable with this one. I generally don't choose. I do not choose this junction. I'm comfortable with this B junction while applying step 1, right? So it is your choice. You can go for E junction or B junction applying KCL, or to follow first step. Neither I go for labeling the nodes. you can label it PQR, small letters, capital letters. I don't know. I mean, I'm comfortable with this A, B, C, D, E, F. You can go with PQRS, whatever you wish, right? So there are certain things which I follow because I'm used to it, right? So that doesn't mean this is anti-clockwise. So I generally don't follow anti-clockwise. I generally go clockwise, right? You can practice at your end to go anti-clockwise, right? So applying KVL. So now apply KVL to loop. Which one? Apply KVL to loop A, B. I'm going for this one, right? I'm going for this loop. A, B, E, right? Then F, then A, back to A, right? And I'm going clockwise, right? Now, if you have solved, sorry, I forgot to name this, put the sign over here. The current is flowing downward, so this end will be positive and this end will be negative. R3, what do I do? This end will be positive, right? And this will be negative, right? Sorry, I forgot to put that signs over there. How I done this? Look at the direction of current. Current always follow from positive to negative, right? So fine. So if I follow A to B, what I see is nothing is there, right? No parameter is connected. Now B to E, I do see what? 2 ohm resistance. So, and I'm, look at this B. Sorry. See this B junction from B to E, current is I1, and I'm going from positive to negative. So there is a fall in potential and I'm going in a direction of current. So I've told you in past lectures that whenever you are going in a direction of a current, so it's ED, right? So it will be 2 minus 2I1, right? Then plus 10, fine. And then why plus 10? Because this one is negative to positive, right? Battery. This one is a battery, 10 volt is a battery. Then we have come across the series resistance 2 ohm, that is R1, right? Which is also 2 ohm. Shall I write this one is R2 and then put the value? Nah, let me do that because otherwise won't be proper. Let me put R2, R2 there, so that directly applying won't up. So this will be minus yes, minus the I1 is
R1 minus
plus
R1.
minus R1 into bracket. What is the current flowing? See, this current is flowing, right? I1 plus I2. So I need to put I1 plus I2 into bracket, right? And that has to be equal to 0. How we are applying KVL, right? We are applying Kirchhoff's voltage law. Right. Now we'll put a value of R1 and R2 and we'll solve this one, right? Let us put the value first. So all the resistances are of 2 ohms, so no need to worry about. Right. So when you solve this one, what you'll get? Minus 4, this one minus, when I solve this one, I'll get 4I1 plus
2I2
2I2
is
is equal to 10, I'll get.
10.
Right, ma'am?
Yes, yes.
Thank you. So this is your equation 1. We only need 2 equations, right? So this is one of the loop. And then let us go for second loop, right? This one. Okay. Now let us go for this loop now. Let us go for this one. That is, let me write down B, comma C, comma D, sorry, dash E, back to B, right? Now let us write down the equation. I'm from B to C. I don't see anything there. Then C to D. Madam, there is a disturbance at your end, please. Okay. From C to D. Now C to D, what I see is R3 is connected and current through it is I2, which is flowing in downward direction. So I'll put negative sign because I'm in a direction of current. There is a fall input voltage drop, right? And what will be, how will you calculate that drop? It is not what
-3, I think.
this will be I2 into R3, right? And then E to D, I don't see anything, right? And from E to B, I see I'm going against the direction of a current. So that will be plus. So this will be plus, right? What that will be, what is that current is I1, right? I1 into R2 has to be equal to 0. Now, if I put this value, when I put this value R1, R2, what I'll get is 2I1 minus 2I2, right, is equal to 0. And this is sufficient. Now that we have got second equation, right? Now we want to solve this two equation, solve 1 and 2 to get I1, I2 and I1 plus I2. That's it. So solving this two equation is easy. So I hope you know how to solve simultaneous equation. And that too, these are all linear equations, so very easy to solve. Anyway, so this gets cancelled out. What you'll get is 6I1 is equal to 10, right? This is what you're getting, right? So your I1 will come out, let me calculate this one, 10 divided by 6, it comes out, yeah. After decimal, I prefer 3-digit, right? After decimal point, it is advisable to write, write at least 6-digit, right? And this is rounding, right? 7 is a round off value, ampere, right? So I1 is 1.667 ampere, and now I can put I1 in one of the equation and I can get I2. What will be the I2? It will be same because these two resistors are of same value, right? Both the resistors are of same value, 2 ohm resistance, so they'll be carrying equal amount of current, right? And if you really want to solve that, you can put that I1 in one of the equation, any one of the equation. You can put it over here either, or you can put it over in this 1 or 2. I'll just directly put the value. I hope you know how to solve for I2, right? Once you get I1, put I1 in any one of the equation and try to solve it for I2. You'll end up getting same value. Why? Because the resistances are of same value. So total, what will be the total current? No, let me. I'm not having enough space. Uh, okay, I'll go for next slide rather than putting it over here. I1 we've got 1.667, right? I2 same 1.667 ampere. Sorry. And what will be the battery supplied current? Total current supplied by battery we know, right? If you look at the diagram, how much current it supplies is I1 plus I2, right? So that will be what, 3.334 ampere, right? So this is the total current supplied by the battery. Now, what will be the voltage across each resistance, right? That we want to find out. That was the question rather, right? What do you mean by that is, let me draw a diagram again. It is better to spend little time on this because otherwise This is 2 ohm, this one is 2 ohm, this one is 2 ohm, this is 10 volt. Now we can write down this is the current supplied by the battery, right? How much current is going is 667 ampere. How much is take? This one is taking 1.667, right? Fine. So if I need to find out the voltage drop across R1, that is this one, no? This one is R1, right? Let me check. Yeah, this one is R1.
R1. This is R1, R2, and
R1, R2, and R3. Okay. So 3.334 is the current through that resistance, right? Through this resistance. So VR1, that is voltage suffix R1. V is the voltage across R1. That will be, how do we find out how much is the current through that? Let me write down here, I1 plus I2, which we have got, into R1. So I1 plus I2 is 3.334 into what is R1 is 2 ohm.
2 ohm.
So it comes out 3.334 into 2 ohm resistance. It comes out 6.668 volt, right? Similarly, voltage across R1, similarly find out voltage drop, voltage drop across R2. Apply same method. What is the current through R2 is, what was the current we took? It is I1, right? So I'll multiply I1 by R2. I'll get what? 1.667 into 2.
3.334.
1.667 into 2, it comes out 3.334, right? So you can notice here, see the drop across this is 10 volt, this drop is 6.66 volt, and remaining the voltage drop across this is 3.334. So if you apply a KVL for this, right, what do you mean by that is, what is the drop across this is
334.
3.334. So if I draw the diagram once again, instead of drawing resistance, let me draw for a given this loop only. See how much is this voltage is 3.334, right? That is the drop across this one. Don't consider is open, right? I'm just trying to, otherwise I'll draw resistance. Let us consider a resistance. Assume that is this 2 ohm resistance. How much is this one is 6.668, and this one is 10 volt. Now if you apply KVL for this, when you apply KVL, add this true drop, it will come out to 10 volt, right? We are taking only, when you add this two, you'll end up getting 10 volt, right? This one. So that is what the KVL says, and that is why I told you to get the voltage across this, so that you'll get to know how KVL actually being verified across the, when you consider a drop across each resistor. So similarly, I can find out voltage drop across R3, right? What will be that is VR3, which is equal to I2 into R3, which is equal to 1.667 into 2, and it will be same volt, right? Because these two are in parallel, so the voltage across both will be same when they are carrying same current. So there are so many things to learn from this simple problem. You can apply a KVL for this, and you can verify the KVL. Right? Let us try to run an animation and uh, get the things whether we have understood or not. Revisit that problem again. This one. Very good. What do I do? This one window. Insert. Dear student, you can do one thing. You can verify this answer at your end. I'm not able to. Insert this one. I'm not able to. Yeah, it is little slow to respond. Yes. I'll go for this rather than going for. Okay, we have got the battery, right? And then this battery is okay, having a resistance 2 ohm means then this branch is also having 2 ohm resistance, right? Okay, take a wire and do the connections. Take this one. Take a piece of wire. See, the current is flowing. I've been yet not okay. How much this has to be? 10 volt. Fine. The voltage source is 10. How much is this? This has to be a 2 ohm, right? How much is this? This also 10 ohm. Make it 2 ohm. We are almost done, dear friends. Give me some time. Okay. Now, if I take a ammeter, how much current this takes? This one is. This branch is not connected, right? Okay. Yeah. Why the current is not flowing through this branch? I don't know. I don't know.
Not properly connected.
I don't know which branch is that.
Delete it, sir, again.
Okay, this okay. I think this is fine. Anyway,
There is no wire at.
okay, I'll connect it over. Now it's okay.
Now
I got
it's okay.
I was making a mistake there. Anyway, so now you can see 1.67 is the current through this branch, which we just got. This is also 1.6, right? How much current battery supply? See, 3.33 ampere. So we are trying to verify our answer, and this is one of the way, and that is why if you are having a facility, see the voltage across this resistance. I'll remove this one, right? I'll just I don't know. I'll take this aside so that we'll be able to understand this. See 3.33 volt, right? And this end is positive. If I connect this over here and this one over here.